My name is Rashawn Redding Michaela, and this is AneDetect, or long name is called anemia detection. So, what is my inspiration for creating AneDetect? So, while I was traveling to many places, I recognized that many people lack that medical assistance in developing areas, right? When people live in villages or when they're really far away from those from those big cities which contain those hospitals, it's really hard to get that medical assistance. Yet many people still have devices or computers or even phones at home, probably maybe from their relatives or if they've saved up to buy it. And the problem is with this distance from the hospital is that many people don't have that transportation to go. Maybe it might be too far, or they might not even have the funds for travel. And they don't have the funds, and they might not have the funds for a professional checkup. For example, to get an anemia checkup, it can cost up to $1,000, at least in US dollars, for getting that checkup. And a statistic that really inspired me and that drove me to start this program is from World Health Organization. It states that 42% of children less than 5 years of age and 40% of pregnant women are anemic. And in supporting the point from before, it's significant in developing countries, which is why it can be a significant problem because many people are getting anemia and they can't get it treated. So I was inspired by this. So that's why I built AneTech to create a program to identify individuals if they might have anemia. And the chart on the left just shows many different symptoms of anemia. So what does AneDetect use? We will go into these points in the next slide, but its primary language is its official language is using Python, specifically version 3.10. It uses OpenCV and YOLO or YOLO version 3, specifically not YOLO version 5, 6 or 7, but YOLO version 3 for object detection and model creation. And I'm using label IMG for a data set creation to create a data set so that YOLO v3 can use that data set to build that model, which OpenCV can use to initialize that program. So how does AnyTech work? So YOLO stands for You Only Look Once software, and it's popularly known for its object recognition and model creation. So it has a lot of functionality. It can take a data set and build it into a model, which is what AnyDetect is specifically using. But primarily known, it's effective in many recognition algorithms. So how does it work? It works by dividing the image provided into the program, and it splits it into grids, and each of the grid has its own responsibility for creating that detection. And then AnyDetect also uses OpenCV for object recognition, and it's just really it's really easy and more functional to use a lot of those functions to really break down that image. And it works by breaking the image or multiple images of the object into dimensional arrays and kind of using that for its detection. And then to create one problem I encountered during creating the program is that there was only one data set for anemia, and that data set was actually locked behind a restriction, so I could not access that. So I had to use I had to collect specific images, a good set of images from Google and create that data set. So to make that data set, I use label IMG, and it just allows to upload that image, and it requires manual identification. So I have to create the data set creates a rect box, and it labels that it looks at the eye, and I have to manually label that anemia. So this right here is actually the Python code that actually starts the program. On the left, you can see the entire code, but on the right is the actual is the main program code. So as you can see, it uses CV2 and uses three other inputs. And basically, as you can see in line 8, it uses it uses the model, and the model is called YOLO V3 training last stat weights. So that's the model that was generated by YOLO V3. That was generated by that cell program or that Google collab, and I will show that in the next slide. And then it uses YOLO V3 testing configuration, and that's just a bunch of resizing info, just a lot of basic info. And then as you can see in 14, this is another primary thing. So it'll go through all the images in the folder anemia P2, which has all the test photos to see if it is able to detect anemia. So it'll go through all those images and check using its training. And this is the Google Colab. This is the computer vision aspect. So for this, I had to use darknet. I also used an NVIDIA GPU from an external source to just make the training faster. The code is not provided here, but the code is on the GitHub demo. But but just to be more concise, this basically um, it downloads the darknet and it pulls over YOLO V3, and then it takes that takes that data set from label img, and then it trains that data set and makes that into a model, which then that previous Python program, which is called YOLO object detection, uses. So it's really effective. And now for the actual results. So there were tens of images that I could have picked, but I picked these three. So if you can, so the top left one, the person has anemia. The person on the right also has anemia, but the person on the bottom left doesn't have anemia, and the program did not detect it because that person did not have anemia. And the program the program has been trained by running for multiple hours, looking at pictures of different conditions of anemia, specifically looking at color and variation in the eye. But yep, that is AneDetect, a very useful program and very and which is still in progress, but it's a very efficient program to detect anemia.